Hello, everyone, and welcome to the webinar. We'll be starting in just a few moments from now. Thank you very much. Hello, everyone, and welcome to the webinar. Today's webinar is on the advanced SolidCAM features for multi-channel programming, and it will be presented by Marina Vilkina. And in the just a short amount of time that she's been already with us, she has already mastered many of our features in SolidCAM, and of course, one of them being the multi-channel programming. So we will start this as soon as possible. We will start this momentarily. Just one note is that we will be, as usual, recording the webinar to be available later on. And the presentation also will be available as well. So without any further ado, I will make Marina the presenter, and you can unmute yourself and show us your screen and get started.
Okay, thank you, Sydney. Can you see my screen? Can you hear me?
Yes, I can. No problem. We hear you very well.
Very good. I would like to say hello and thank you for joining the webinar. In this session, we will talk about special SolidCAM features for multi-channel and Swiss type machines that help us to support different access mode for such type of equipment. As you know, Swiss type machining providing a cost-effective way to produce small, complex, and precision parts in large quantities. Multi-channel machines and Swiss type machines increase our opportunities in productivity gains, utilization efficiency, and mass production. One of the reasons is special access combining modes, which makes machine very competitive, but programming becomes more complex. In the main issue of this webinar is to describe rules for access control from machine side and to show how you can manage with it from SolidCAM. Access modes depends on machine structure and its kinematics. Please refer to the programming manual and other machine documentation to check what modes can be used for your machine. Generally, we can divide access combining modes on 4 groups. You can see these groups on the screen. It's access synchronous control, access mixed control, balance or pinch cut, and simultaneous machining. I will consider each group from machine side and show a real examples of combining modes inside SolidCAM. The first group is called Access Synchronous Control. I decided to start from this group because it is always used when you're doing cutoff on Swiss type machine. Also, this type of access control is used for operations or with part clamped in both spindles. Before I will start to explain programming rules for the mode, I would like to pay your attention on CNC limitations which force us to use special commands. The first rule is determinacy. CNC controller can't have 2 Z or X axis movements in one line of program code because it ruins determinacy and machine is confused with what you can mean with such command. If you ever operate on one channel mill-turn machine with sub-spindle, you should know that D-move of turret is never performed with Z-move of sub-spindle in one line of the G-code. You can do it only step by step and in 2 different lines. And here we have our second rule, special for multi-channel machines. Know your machine and access permissions. You should clearly understand what is going on. Therefore, we have the third rule, G-code form. It is really depends on current machine. You can use 2 machines from one supplier, but from different generation, and your G-codes will really differ. First of all, remember about your limitations and you will understand behavior of the machine. On the left part of this slide, you can see two diagrams explaining the meaning of synchronous access control. The first one is from Fanuc documentation and the second one is from Mitsubishi documentation. This is one of the examples of such control, the most widespread. As I said, you can't have two z-axis movement in one line of the code, but in meaning of machining process on Swiss type machine, you need your Z2 subspindle axis to support stock, which is moving by z-axis too. And in means of such control, you should choose which axis will be leading and which will synchronous follow it. We call it master and slave axis in SolidCAM, and machine manual call it reference and synchronous axis. For the current diagram, Z2 is controlled by Z1. Stock is clamped in both spindles and cutting is performed by X1 axis of gang tool. We completely rely on Z1 axis and program its movement in the code and completely sure that Z2 is moving exactly the same way with the same feet. This mode was created to support cutting of long and thin parts, to have ability to turn and cut off without damage and blending of the part axis. On the right side of the slide, you can see the explanation of this mode from programming manual. Now we can go to SolidCAM functionality to see what tools we have in the software to manage axis synchronous control. There are pictures of machine control operations on the slide. And we have a special axis synchronization function for main spindle. Just make it active and choose your master and slave axis. Here we have two machine configurations with 2Z axis on the left picture and with 3Z axis on the right picture. SolidCAM tools lets us to choose synchronous mode that we need depending on machine kinematics. Synchronous control is enabled with MCO operations, but do not forget to create all procedures that your machine needs before and after it. Subspindle should be positioned and clamped, spindle speed and phase should be synchronized. Let's go directly to SolidCAM and take a look on a regrip example where such type of control will be used several times. Here I have a long and thin part, and let's first take a look on the machine itself. This is a Swiss type machine with two tool blocks for the main spindle, one of it for OD toning on the right side and one for the OD toning for the left side. This is live tools. This block is for operating on a subspindle for drilling and milling operations. And also we have the tools on the subspindle. We use this machine several times today. This is a long and thin part, and to machine it, we should divide it along its length on several pieces. The length of each piece will depend on guide bush collet and available retract distance. So what we're going to do, we will start from the main spindle. We're doing facing and first turn operation to pull part out of the main spindle. Then we will prepare our subspindle, pull it more from the main spindle to make a first grip operation, close our sub-spindle. We will turn on our synchronous mode. Then we will perform the turning with the synchronous status of Z1 axis. Turn our mode off. We'll repeat the procedure of regrip. We'll pull out the part, move our subspindle again, turn on synchronous mode, and turn again. So this is the normal process for the long parts. As you can see, all these movements we will perform with MCO operations. We have our MCO operations as MCO cycles to make programming more easier for a customer, especially for such operations which is common for the long parts. Let's check our simulation on the machine. Here is our machine, and we have the facing operation, the first turning operations in 2 cards. Part is pulled out from the main spindle, and now we are ready to make a first grip operation with the sub spindle. We have our safety distance, our distance of clamp. We can easily calculate the distance for the back spindle to not damage our tools and to support all limitations of the machine with this simulation window. Now we turn on our synchronous mode, and we can cut with the one tool and with 2 spindles to the axis. They are moving synchronously together. Making regripping again, turning again. So this is how we can machine our part. Let's go back to the presentation and move further. The next axis combining mode I would like to review is axis mixed control. On the left side, you can see 2 diagrams from machine manual explaining mixed control mode. On the upper diagram, we can see a basic controlled axis layout. We can call it normal axis pattern in terms of SolidCAM. That means we can machine with Z1, X1, Y1, and C1 on the first channel, and Y2, Z2, X2, C2, and Z3 on the second channel, without applying special commands. The lower diagram is showing what axis we can use to mixed control. It means that same axis from the first channel can be controlled by the second channel with special cross-axis control function. It is a very interesting situation because basically the main channel for the major machines is the first channel, but for machine that we will review today, the main channel will be second channel. Please pay attention on the header of the slide. I have found 3 different names of mixed control in machine documentation. This means that you should be careful and do not rely on the name of the function, but clearly understand what is going on the machine to choose right functions inside the SolidCAM to program mixed control. And on the right side, we have explanation of mixed control from machine manual. It says this function enables any axis to be replaced by another axis between part systems. With this function, an arbitrary axis can be exchanged freely across part systems. This makes it possible to perform operations which are not possible in regular axis configurations. For instance, tools which are provided only on part system 2, it means the first channel, can be used for machining on the second channel. The name of function can vary depending on documentation and CNC. And here we can see a nice graphical explanation of replacing axis example. Here is the normal pattern, basic control axis. We have X1, Z1, and C1 on a first channel, first part system in terms of dictation, and X2, C2, and Z2 for the second part system. Now we're applying a mixed control, mix X-axis and X2 axis. This means that we can use X2 axis on a first channel, first part system, and X1 axis on a second channel, second part system. This slide illustrating a part and machine example, which I want to show you and explain mixed axis control. Before I will go to the SolidCAM window, I would like to mention SolidCAM tools that used for cross-axis control. Currently, we have two ways to switch control, using submachine combination and using axis pattern, or we can have both of them depending on the machine kinematics. On the central part of the slide, you can see axis pattern window, which we can apply inside synchronization table. Let's look more closely on the machine and axis layout. I will move again to a SolidCAM window and open my new project to show you a replacing axis example. It looks like a very simple part, but before we go into the cutting process, I would like to show you the machine itself. It's a very interesting machine because it has a turret and it's a Swiss type machine with turret. It's not so widespread kinematics structure, but we have more facilities with such types of machine because we have three Z-axes here. The first one is the Z1 axis of the stock. It can move, and we have a gang tools, OD tools, and live tools here. We have our turret. It can move and operates as usual turret for two-spindle Milton machine. So it has its own Z2 axis. It has separate X2 axis. So we have two X-axes on this machine. And also it has a Y-axis, and it can operate for the both spindle, as you can see from the tool blocks here. And we have the Z3 axis for the back spindle. This structure let us apply different configurations for the machining on the main spindle. We can machine the part with Z1 axis and X1 axis. It's not machining like we usually can perform on any Swiss type machine. We can perform it by pulling out our stock, fix it, and operating with Z2 axis and turret. It looks like machining on a simple turn and turn mill machine, lathe machine. And also the third mode, which we will perform today and right now, is providing by X2 of the turret and Z1 of the stock. For this option, we really need exchange our axis. And to show you all this mode, I created very simple operations here. This is the face and turn with my gang tools, so the tools. Then I prepare my stock, pull it out for the turret, and for the turret cutting. And I perform my hex with Z2 axis and turret. Z1 wouldn't move. And the third operation will be turning with turret with Z2 axis and Z1 axis. Okay, what tools do we have to perform all those operations? If I will go into the operation itself, I can see on a tool tab my sub-machine choice. I can choose here what type of z-axis with turret I would like to apply to these operations. And as you can see, I don't need a lot of preparations here. I just made a normal list of procedures that requires with this machine. I should prepare my turret to make a tool change, and I should move my stock to the sufficient distance from the called noise. In my synchronization table, as I said, it's a very interesting machine because the second channel is like a main channel. It can perform more operations. It can take control on more axes, as we saw on a diagram on the presentation. And we have our third turning operation with turret and Z1 on the second channel. And on my first channel, I can have only Z1 cutting. Okay, now we are ready to check the simulation. We will see this machine later on other examples and with other combining modes. Okay, here we go. The first operation will be performed with gang tool and Z1. We prepare our turret. We can move it, turret home operation, we can move it out from the main spindle, and now we can operate with gang tool. Doing facing, doing some turning, and then we're moving our stock, pull it out to prepare our milling operation with the turret changing tool. And perform some milling motions. Now we are ready to perform the third operation. It's turning with turret and Z1. As you can see here, we should manage with control our X2 axis. Its position for Z2 axis should be like 0 for this machine, and then we can operate with X2 axis and perform cutting with Z1 axis. This is performed with MCO operations. So that's all. We just choosing the right submachine inside the SolidCAM, and for this machine also, because of variety of modes, we also will choose the right axis pattern here. We can do it from the channel synchronization table. It's a very powerful tool to doing all the synchronization operations and turn on all the synchronous modes for access inside the SolidCAM. Okay, we can go back to our presentation and move further. Another example of mixed axis control is axis exchange mode. In compare with previous example, where we had a possibility to choose which z-axis to use for machining, and we had several axis combinations to perform turning, the next example will show that some machines hasn't sufficient amount of axis to provide cutting without axis exchange mode. Let me show you one of widespread examples of tool posts which needs mixed control function to cut apart. Before I will switch to a screen to show you CAM part, let's look on the tool block showed on the slide. This is a very common situation for the Swiss type machines. We have a a double tool block, so it can operate on the main spindle, and it has the live tools, and also it has the drilling tools that can't rotate, and the same tools for the second channel for the sub spindle. And of course, we need to choose what we're going to do with this block and how it will be operate. It's not a problem for the main spindle because it's a normal pattern for the main spindle. But for the back spindle, we should understand what machine needs to program these tools. To operate for this particular machine, it needs to position the tool. So we will operate with X1 and Y1 axis. Then we will move our subspindle and will perform the cutting with X2 and Z2 axis of the spindle. But X1 and Y1 axis are still online. They still needs to be managed. We can't just switch on the subspindle and perform the cutting. That is why we will apply the exchange mixed control for the axis. You can see on the right side the example of the real example of the real code for this machine. This says Mitsubishi controller, as you can see from the weight marks, and we have G140 command, and we should say what axis will be mixed on the first channel. Actually, as you can understand, Z2 and C2 axis should be controlled by second channel. This is normal situation for this machine. But for this particular operation, we should apply Z2 as Z1, so we turn on control by Z2 with the first channel, and C2 axis is controlled on the first channel too. With this command, we completely switch the control with this axis on the first channel. After this command, we can operate with this operation. We can create a tool path, and we will have our tool path. We will have our code on the first channel. It will be the first program, but we will see our operation, our cutting with the subspindle. This example of the code shows that we really need information about the machine to clarify machine modes and to find out possibilities of the machine. Now we can move to the SolidCAM again, and let's move closely on the machine and this example. Okay, here is our machine. It has quite common structure, so it's gantry tools, OD tools, radial tools, live tools, axial live tools, and drilling tools, double block, and back tools for the subspindle. We will make some operations on the main channel, then doing cutoff, and then making some facing operations with back tools for on the second channel for the subspindle, and then the last operations will be with mixed control to machine these areas. This is our procedures in synchronization table. So we performed some operations on the main spindle, made a cutoff operation with synchronous mode that we covered before. Then we send our subspindle to home position, making some facing operation for the second part, second side of the part, the back side of the part on the second channel, and then we can turn on our special mode. We do it with the MCO operation. And here we can see that our operation for the sub spindle is performed on the first channel. Then we can do ejection. Let's take a look on simulation. Okay, and here is our operation. So we position our tool block, double tool block, as it requires with the machine. We did it with the MCO operation. Now we can mill it with movement of the sub spindle and perform this simulation with Z-axis. So it looks quite simple and easy to program. Let's go back to the presentation and move to the other mode. Next axis combining mode we will cover today is balance cut. Balance cut means that your machine has facilities to cut the same contour with two tools. Therefore, you can machine faster and with more rigid conditions. There are two types of balance cut: turning and milling. As you can see on the left picture, we have two turrets with turning tools. Upper turret is managed with first channel and lower turret is controlled with second channel. And they have two separate Z-axes but have to share one drive unit, which is performed by stock rotation. In case of Swiss-type machines, one of Z-axis is stock axis, and cutting profile is the same for both operations. Pinch milling has two separate drive units, which is performed by tool rotation, but during this process, they have to share one or more axes. For example, they are using one Z-axis. And to perform balance cutting on the machine, you have to remember about all machine limitations you may have. Let's look more closely on pinch turning. On the right side, you can see a list of advantages of pinch turning. When workpiece that is relatively long and thin is machined on the lathe, deflection may result, making it impossible for the workpiece to be machined with any accuracy. In this case, if the cutters are applied simultaneously from both sides of the workpiece and the workpiece is machined while synchronizing this balance cut, the slack can be suppressed. This method has an additional advantage. Since the workpiece is machined by two tools, the machining time is reduced. On the left side, there are some pictures from balance rough operations from SolidCAM. Turning operations can be converted to balance in SolidCAM. Let's go to the SolidCAM project with balance rough balance turning example. We go back again to the part, but we will machine it with balance turning right now. So this is very simple. We just create a turning operation and we just add a balance rough to it. The main condition is that we have the machine that can perform this type of operation. So here we have this machine we covered before, and this machine has two Z-axis to machine on the main spindle and two separate X-axis. So we can easily perform the balance cutting here. So inside the operation, I can choose my master and slave tool, and I can choose what type of submachine I can use here. Also, inside the Synchronization table, I can see all my information about mode that I will use. Z1 axis will be superimposed for these two operations, and they will share the drive unit. I don't need any preparation. I don't need any special MCO cycles here. I just moved my turret to the position to perform this operation. The position for the turret can be trailed or it can be simultaneous. So the two cutters will start from one point. Let's check our machine simulation. Okay. That's what I said. Tools should be positioned in the same point by z-axis to start this operation. And now we can perform the balance cutting for the contour. They share one contour and they share one unit and they share one axis. That is what is called balance turning operation. Okay, pinch milling means you cut one operation with the same geometry and the same strategy with two tools. And to perform such cutting, you should synchronize one or more axes for operations. The next example, which is showed on the slide, performs machining with turret and gang tools. Two live tools are sharing Z1 and C1 axis to perform pitch milling operations. Now I will show this process inside the SolidCAM. I will turn on my project for balance milling operation. Now we can see the same part with the balance turning and balance milling. It looks like simple contour operations here, but I created these operations with different submachines and with different tool posts to machine. The first one is for the gang tool post and the second one for the turret. And of course, before this, I should position my turret. This part will be cut on the same Swiss type machine with the turret. In synchronization table, we can see the status of all axes. We can see our balance operation, position of turret, and synchronization sharing Z1, C1 axis for this operation. Let's go to the simulation. And check how it will looks like. Okay, here it is. It's a simple example just to show the process of pinch milling on such type of machines. Of course, we can add more complex operations here. The last axis combining mode I would like to describe today is simultaneous machining. Simultaneous machining means that two tools are cutting together one piece, one part simultaneously. In compare with balance cut, these tools do not share the same operations. Both tools have their own operations, for example, turning and drilling, but because they have two to operate on one piece of part, they have to share drive unit and or one axis, depending on situation. On the slide, you can see several examples from machine documentation where simultaneous mode combining turning and drilling and turning with boring operation. I will show two examples of simultaneous machining. The first one is what I call double drill. This is very popular and common operation for two sides tool blocks. In this case, tools do not share one piece of part. They share axis and two operations are machined simultaneously. Each operation has its own z-axis and drive unit. You need to position tool and stock and start with the same weight mark. Let's go to the project. With double drill. Now let me introduce you the machine I will use for this project. So that's what I called the double drill block. It can be horizontal or vertical, but the meaning of this block is the same. We can put it along the axis, z-axis of the machine, and machine it with z-axis and z2 axis simultaneously. This is a very simple operation, very simple to represent inside the SolidCAM. The main requirement is that you should create a cutoff operation and ejection operation. So like you release the part and load the new workpiece to the synchronization table, and SolidCAM knows that it has now it has two pieces of the stock and can machine it separately. So here is our drill operations. As you can see, I didn't create any additional MCO cycles here. I just put it together under one weight mark and have my synchronous movement. Let's check machine simulation. Here it is. Tool just positioned and stock is ready to be cut. We can check the time of the operation and feed and speeds to plan our operation, to control it completely with synchronization table. This is our double drill example. The next example is more complex because tools will share part, axis, drive unit, and we will need axis pattern to describe determinacy conditions to perform cutting. In the upper part of the slide, you can see a picture of a synchronization table where you can find all information about axis combining status. We can see here that tools are sharing Z1 axis and main spindle drive unit and the special axis pattern where Z1 has superimposition status is applied. Okay, let's check this cutting inside the SolidCAM. First of all, I would like to show you the machine itself because this mode is supported not with the old machines, Swiss type machines. This is a citizen machine, and we will perform cut with OD tools and with sub-spindle tools. They can work simultaneously using the special axis pattern, which is described in the documentation for this machine. So it will be our groove operation and drill operation. We can check its status inside the synchronization table. Here they are, as you saw on the slide. And I think now we can go to the simulation. And check the cutting process. Here we have drilling and grooving operations, simultaneously cutting together. Okay, it was the last example for today. I hope you enjoyed the session. You can add your questions now or send it after the webinar. Thank you for your attention.
Okay, Marina, thank you very, very much. That was very well done. There were some questions that were asked, but I did answer them already. One of the questions was if what modules do you need to program Swiss type machines? And I believe the answer to that is you just need the regular mill turn module, as well as the post processor, and of course you must have machine simulation. That's as far as I know. Do you know anything else about that?
Yes, I think there is a need in a multi-turret model to operate with the
Okay.
synchronization table. Also, we have the new configuration, especially for Swiss type machines. It's called like a Swiss type model, which includes all the basic modules that you need. And you can add more modules there depending on your parts, because we may have the parts with HSS operations, I mean more complex milling operations and machining operations, and we have a very nice webinar about the configuring of the modules for the Swiss type machines. Nevertheless, we have a special Swiss type configuration for the SolidCAM, which includes all the basic 2D operations, turning operations, and synchronization table. And of course, machine simulation, if you would like to provide collision check and see all your parts of the machine and see the coordinates of the machine parts when they're moving and the limitation for the axis.
Right. In fact, machine simulation is very important, especially when it comes to Swiss type machines, because they're really small and you really have to see everything that's going on there because there's not much space in there as it is. Okay, now again, the webinar has been recorded, and this and the presentation will be available, I believe, by tomorrow on our website for everyone to review as well. Okay, Marina, again, thank you very much for the webinar, and everyone have a great weekend, and we'll see you at our next webinar. Take care.
Thank you and goodbye.
Bye-bye.